talk to you about the derivation of the binomial distribution, or at least the intuition behind it. Okay, so the binomial distribution, the setup is really important, and you need to be able to identify the distribution. So the setup of the binomial distribution is that you have what's called repeated Bernoulli trials, a fixed number of them in particular. So we say we have n Bernoulli trials, okay? And a Bernoulli trial is just an experiment in which you have only two possible outcomes. You can think tossing a coin. There's heads or tails, or success or failure. P is the probability of success, and Q is the complementary event, which represents the probability of failure. Okay. In these Bernoulli trials, because you're repeating it, think tossing a coin, the probability of success does not change. That has to be fixed for each trial. Okay. So these are the conditions for the binomial distribution to apply. We have to have a fixed number of trials. One trial, or toss of the coin, does not affect the other. It's independent. There's only two possible outcomes, success or failure, and we have a constant probability. Okay, so what's the idea behind the binomial distribution? Well, in general, we want to know what's the probability of k successes. If we're tossing the coin n times, that means we have n minus k failures. So for example, if we toss a coin 3 times, we have 2 successes, or 2 heads, and we have to have n minus k, which would be 3 minus 2, which would be 1 failure. One such instance of this would be success, success, failure. And the specific probability for this outcome would be P times Q, because it's success, or heads, n failure. So P squared times Q. But there's many ways in which this can occur. So for example, we could have failure, success, 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 failure, success. And so we have to count all the ways in which we could have 2 successes out of 3 trials. This is a combinatorics problem. So how many different ways can we get exactly k successes in n trials? Keep in mind, we don't care about the order here. We just care about having k successes. So if we do this, the number of ways that we could do this is given by n choose k. Okay. So in the case of tossing a coin 3 times, we want the probability of exactly 2 heads. Well, n choose k would be 3 factorial divided by 2 factorial divided by 1 factorial. So 3 factorial divided by 2 factorial is 3. And so there's 3 ways to get 2 heads, when you toss the coin 3 times. And let me just show you what those outcomes are. So I'll title this tossing a coin 3 times. How many ways can we get 2 heads? So I think one specific outcome would be heads, heads, tails. Another one would be heads, tails, heads. And then a third outcome would be tails, heads, heads. And one thing that I want to pick off from this is that, if you do this formula here, so n is 3, So n is 3 tosses of the coin. Two heads. And these should be lowercase. So let me do that. So this will give us, so 3, 2, 3, 2, 3, 2, and this is going to be equal to 3. So we know we have them all. Okay, so, and we listed them right here. Okay, so this combinatorial object counts them correctly, and so the probability of having k successes out of n trials is given by this binomial formula. So in the setup of the binomial distribution, x is the number of successes out of n trials, okay? And k is the particular value you're interested in for the successes. N is the total number of trials, p is the probability of success, and 1 minus p represents q, or the probability of failure. So let's consider an example application of this. Okay, so it says here a manufacturing company produces light bulbs. It is known that 5% of the light bulbs produced are defective. If a random sample of 20 light bulbs is taken from the production line, was the probability exactly 2 of them are defective? So we have 20 trials because there are 20 light bulbs. They're either broken or not. There's a 5% chance of failure, so p is 0.05. There's a 95% chance they're working. What's the probability we obtain exactly 2 defective light bulbs out of the sample of 20? So we're going to use this formula here, and in Python you can make all the definitions here, and you can calculate the probability, or you could just plug in your calculator. N is 20, k is 2, p is 0.05, and use this formula here with k equals 2. Okay, that should give you 0.007, or you can use a stats library in Python. So scipy.stats, and we'll import the binomial distribution. We'll use these parameters, and then we'll calculate exactly the same value right here. Okay, so I hope this gives you some insight into how the binomial distribution works and why we have that formula.